Hello everyone, and welcome to our Linux tutorial for turning our Spotify car thing into a Debian powered kiosk. Let's see how we go about doing this. So I know I already went over what the Debian Kiosk is during our other Spotify car thing video, but a quick recap. On the Bishop Dynamics GitHub page, there is a pre-built Debian 13 𝗙𝗃𝐺𝐸 image designed specifically for the car thing. This image installs a Chromium-based browser in full screen kiosk mode, effectively turning the car thing into a dedicated web app interface. You can use this for things like Home Assistant control or any other kiosk style application. It replaces the default Spotify functionality and provides a full control via SSH, VNC, and the device physical buttons. Currently not working is Wi-Fi and GPU acceleration. Now, if we were to rebuild the bootloader, we could get these features to work, but that is more for a later date. Quick disclaimer, I'm not responsible for the bricking of your device. Follow this tutorial at your own risk. So now that we know what we will be installing, let's talk hardware prep. We'll need a laptop, desktop, or virtual machine running any Linux distro. I will be using a Debian virtual machine, but you can use Ubuntu, Arch, Fedora, or anything else. We'll also need our Spotify car thing, its USB cable, an Ethernet cable, which is optional, a micro SD card, some device to act as a host like a RAD XA0, Raspberry Pi S, Raspberry Pi 4, and a power cable for it. I will be using a Raspberry Pi 4B, by the way. Now for our software. Now most of the tools needed are just for flashing the Spotify car thing with the Debian image, and we'll just cut down to what we actually need. We need to install Python, libusb-dev, git, multistrap, and pyml-boot. Now if you're not using a Debian image, you will need to fix the pyml-boot by breaking the package. We can do so by typing in sudo python3 pip install the GitHub link -- break system packages. Now we're also going to need to get the 𝗙𝗵𝗺𝗲 tool, the Debian firmware, Balena Etcher or Rasp Pi Imager. Those two we'll download later on when we cover those. And technically we will also need the Raspberry OS bookworm light image if we use Balena Etcher, but just like the other tools, we'll get to that later. You can get the 𝗙𝗵𝗺𝗲 tool from Thing Labs OSS, hit code, and hit download zip. The firmware under the Bishop Dynamics GitHub page, 𝗙𝗵𝗺𝗲 Debian Kiosk. Here on the right side, we're going to hit this and hit download for tar.gz. Once everything's installed, go into your folder where everything is downloaded to, extract the 𝗙𝗵𝗺𝗲 tool, and then also extract the Debian image file. Now the Debian image file is about 1 gig in size, so it will take a little bit of time to actually extract into a folder. Just to make it easier, rename this Debian file to firmware, and then place it in the 𝗙𝗵𝗺𝗲 folder. And that's pretty much all we need at the moment. Let's get into flashing this firmware. Just like each time before, plug your Spotify car thing in, holding buttons 1 and 4, and wait for the chime. Now the screen should stay off. If you have the 𝗙𝗵𝗺𝗲 tool folder open, click the 3 dots and click open in terminal. If you have closed it, just open up the terminal and cd into that folder. Now we can run sudo //𝗙𝗵𝗺𝗲tool.py --find_device. Type in your password. And our device is founded in USB mode. Now we can run the same command, except this time run restore device, and then the directory for that firmware, so do /firmware, and hit the enter button. Now we don't need to enable burn mode or rename any of the file extensions. Everything has actually changed since our initial Flash tutorial. Everything was stated in our most recent Flash tutorial. Alright, while that runs its course, let's just talk about any issues you may have flashing the Spotify car thing. First, try another USB cable, another USB port directly on your system, no USB hubs, the 𝗙𝗵𝗺𝗲𝗲 tool in the description below, ensuring all these software tools are downloaded and updated, and then comment down below if none of these seem to work. Alright, while that runs its course, let's prepare our Raspberry Pi. Take your SD card and plug it into your computer. Make sure it's blank before you actually do anything, as it's going to remove all the data on the micro SD card. Earlier I said we can use Balena Etcher or Rasp Pi Imager. We'll start with Pi Imager and then we'll cover everything with Balena Etcher. For Raspberry Pi Imager, using the link to the description below, go to raspberrypi.com, scroll down until you see install Raspberry Pi OS using Raspberry Pi Imager, and hit download for your version of Linux. Now I'm using Debian, so I'm just going to install via the command line. Open up another terminal window, sudo apt install RPI Imager. Type in our password, and everything's updated and installed. Open up Raspberry Pi Imager. Select our device. I have a Pi 4B. Then for our operating system, we want Raspberry Pi OS, but we want Bookworm and Lite. So we'll go under Other. Raspberry Pi OS Lite 64-bit. And then for our storage, we have our micro SD card. Make sure you select the correct one. Last time, this will wipe everything. Click Next and hit Edit Settings. Now for settings, here are the ones I highly recommend. Go to Services, enable SSH. Then for username, type in Pi and Raspberry. Configure your wireless LAN to your name and password. And then hit Save. Hit Yes again, and then let it run its course. While it does that, I'm just going to quickly touch upon why we chose those settings. Just using the default username and password tries to cut down on outside variables, trying to keep them all standard. Next is our network. Now, not everybody has access to the router or an Ethernet port, so we want to connect to Wi-Fi to easily SSH in later. This does mean that we need to scan the network for the Pi's IP address. This can be as simple as downloading an app on your phone or PC. I highly recommend Angry IP Scanner and running that. Once the flash is complete, eject your SD card, plug it into your Raspberry Pi, and let it boot up. This initial boot will take some time. I suggest waiting at least 5 minutes until you scan the network or do anything. The Pi will reboot a few times during this. Now, whether you did the Wi-Fi setup or connected your Raspberry Pi to your router via an Ethernet cable, you can skip the timestamp on screen. Next up is our Balena Etcher setup. Following this, we'll also state how to set up local SSH. For Balena Etcher, links will be down in the description below. We need to download Raspberry OS Bookworm Lite and the Balena Etcher tool. For the Raspberry Pi OS, on the Raspberry Pi website, scroll down to see all download options. Raspberry Pi OS 64-bit. Right here, Raspberry Pi OS Lite. Hit download, and it's going to download an img.exe file. For Balena Etcher, just hit download Etcher, and we're going to be doing it for Linux. Now we are running Debian, so technically we can look for the .deb package. This will take us to a GitHub page, and we need to download it on the GitHub release page. This one. Now this only applies to if you're using Debian. We're going to do sudo apt install /Balena Etcher and the .deb file. So under our downloads, here's our .deb file. We can open this in a terminal. Sudo apt install Balena Etcher. Password. Hit yes. Now for Balena Etcher specifically, we don't need to extract this img file like I said before. Now that everything is finished downloading and set up, open up Balena Etcher and select our image file. Then select our target, which is our micro SD card. And then hit flash. Wait for the image to finish flashing onto our SD card. Now that it's done, we still need to do a few things. Open up the fresh boot file system on your PC. You may need to eject and reinsert the SD card. Now, because we're using Linux, we get access to both the root FS and the boot FS. Under boot, we are going to create two files. The first one's going to be a blank text file called SSH with no extensions. Put it in boot.fs, just type in SSH with, again, no extensions, and hit save. If we check, we should see it right here. And then we're going to create another file called 𝗙𝗹𝘀𝗵 another text file, 𝗙𝗹𝘀𝗵. Hit save again. And this time we're going to put the following information in to connect it to the internet. Now, don't forget to change your SSID to your network name and your password to actually be your password. Save, close, and eject your microSD card. Plug it into Raspberry Pi and plug in your Raspberry Pi to a power source and let it boot up. Now, for Balena Etcher, you will need a keyboard and mouse to actually set up the device. Turns out a couple years ago they removed the default credentials for Rasp Pi OS. So if you want to set it up without a monitor, here on screen are the three screens that come up. First, put a username in, then hit the enter button, then put your password in, hit the enter button, and then re-put your password in and hit the enter button. And then it should boot up and you should be able to do a local SSH or just plug into Ethernet and then you should be good to go. Now, I'm also going to mention that the 𝗙𝗹𝘀𝗵 file should also work, but if not, try the local SSH and set up Wi-Fi that way. Now, whether you did the Wi-Fi setup or connected your Pi to the router via an Ethernet cable, you can skip to the timestamp on screen, as now we're going to be figuring out our local SSH from your PC into the Raspberry Pi. Alright, so your Raspberry Pi is finished booting up. You've plugged your Ethernet cable from your Raspberry Pi into your PC. And now we need to connect our Raspberry Pi to the internet so we can then SSH into it that way. So there are two ways we can do this. If you used Rasp Pi Imager and selected Raspberry Pi.local, we should be able to SSH in through Raspberry Pi.local. If that doesn't work, we will change our IP address to be static, and then we can SSH in through that specific IP address. So to check if Raspberry Pi.local works, we're going to open up a terminal and then just ping it first. So ping Raspberry Pi.local, and because it says name or service not known, pretty much just means that we have to set the static IP address through our internet itself. Now, somebody in the comment section is going to be saying that I'm doing this wrong. Probably true, but this is how we're going to do this now. So go to your internet settings, hit wired settings. Now this is only for Debian. Any other Linux distribution, you will just need to get to the network settings through settings, and then we'll go to our connected interface, hit settings, and here's our current IPv4 and DNS and everything. We need to make this under manual. IPv4 is perfectly fine. For IP address, we're going to put 192.168.1.10. For net mask, we're going to do 255.255.255.0. And then gateway, we're going to do 192.168.1.1. That's it. That's all we need to do. Hit apply. Give it a minute. We may need to restart our network services. But once that's done, we can exit out of this and go back to our terminal. We're going to do SSH, the name that you put for your Raspberry Pi, at 192.168.1.1. Now mine is saying connection refused. It just means we may need to reboot our network. So we can do that by typing in sudo service network manager restart. Type in that password. If that service isn't found, just type in sudo systemctl restart system d network d. And then we can re-SSH into that Pi and see if it connects this time. Alright, now that we are on the connected Raspberry Pi, let's connect this thing to the internet. Type in sudo rasp config And it's going to bring us to this system settings. Hit system options, wireless LAN, enter in the SSID of the Wi-Fi network, and then you're going to enter in the password for the network. Once it's connected through, it's just going to kick you out to the main menu. Hit update if you want, and then just hit finish. And now the Raspberry Pi is connected to the internet on the Wi-Fi network. Now we just need to reboot the Raspberry Pi, scan our network for its connection on Wi-Fi, and reset our wired connection. Just change it from manual to automatic. Reboot our network adapter, and then we'll be good to go. You've done everything and your device still won't connect to the internet. Try using a different version of the Rasp Pi OS and maybe use Balena Etcher instead of Rasp Pi Imager. Alright, now that our host device has booted up and connected to the internet, let's actually get this thing set up. Open up a terminal window and SSH into the Pi using pi in the IP address of your Raspberry Pi. Type in yes for fingerprint, and the base password will be raspberry, all lowercase. And now we're on our Raspberry Pi. We can type in sudo apt install and git. If it's not already installed, just run through the setup process. If it gives you any issue, just type in sudo apt-get install git. And next up, we can clone the repository. Type in sudo git clone. And then the easiest way is to just copy the link in the description below. Or if you need to, go back to your web browser, go to the Bishop Dynamics GitHub page, 𝗙𝗵𝗺𝗲 Debian Kiosk, and copy this link. Paste, and hit the enter button. The download won't be too large, as just right there, it finished. Let's cd into the 𝗙𝗵𝗺𝗺 folder, just downloaded. And type in sudo bash setuphost.sh. Now it's going to set up the host device to actually run our Spotify card thing. Now the setup process isn't too long, 2 to 3 minutes, depending on your network speed. Alright, now that it's done, it has added the following IP address of 192.168.7.2 𝗙𝗵𝗺𝗺 into our host, which this will be our Spotify card thing. Now that that's done, just type in sudo reboot, and it's just going to reboot our Raspberry Pi, and that concludes our Raspberry Pi setup. By now, our Spotify card thing should be more than done flashing. We can unplug it from our PC and plug it into our Raspberry Pi. Now there are 3 boot modes that the new Spotify card thing has. Holding the first button puts the device into ADB utility mode. Holding button 4 puts the device into USB burn mode. And then no buttons at all is its default boot option. We're going to stick with the default boot option for this. Once it boots, we should be at the Chrome screen with the failed attempt to connect to an IP address website. SSH into our Raspberry Pi with our default creds of Pi and Raspberry. Now here's where things get a little tricky and might not always work. SSH into our Spotify card thing, doing SSH 𝗙𝗵𝗺𝗺 or 𝗙𝗵𝗺𝗺@192.168.7.2, and the password is 𝗙𝗵𝗺𝗺 in all lowercase. If you're not able to get on it, you do need to type in sudo root add net 192.168.7.0 netmask 255.255.255.0 deb USB 0, and then you're able to actually SSH onto this. I actually spent quite some time trying to figure this out. If you can't get onto it, let me know down in the comment section below. I'll try my best to assist you. But now that we are onto it, why don't we check out what we can actually do. First up, we're going to cd into our scripts folder. So type in cd:\scripts. Now that we're in our scripts folder, let's go into Chromium settings.sh. And here is the URL that we see in the beginning when it says, this site cannot be reached, 192.168.1.144, the port, and then Lovelace. all we need to do is change this to pretty much anything for it to connect to that specific site. Now this is more for home automation or anything you want to use that the Raspberry Pi can connect through. We're just going to put Google here to check it out. Hit Control S, Control X, and then we're just going to reboot this by doing sudo systemctl restart chromium.service. It's going to restart our Spotify car thing, and then it's going to boot up into Google. Now we can even touch on Google and everything for trending searches will come up, but the keyboard does not want to come up in this state, which, I mean, it makes sense. Now, there are multiple things we can do. We can change the button settings. We can also change the default screen timeout, the default orientation, the backlight for brightness, and then also change the VNC password. Now, there are a lot more to this, but those are the ones we're going to take a look at first. So we're going to check out the button settings by going to nano buttons settings.py. Now here's everything that you're going to need to modify each button. Here's just an example for the Home Assistant address, the token for it, and pretty much everything else that Bishop Dynamics used in his example for the GitHub page. Now this isn't limited to just this. It just shows, for example, that this is where you want to do to modify the buttons. If we exit out of this and go into X11 XORG, here we have the just basic XORG configuration for the Superbird, and here's where the default orientation will be. Now portrait is the current orientation with the buttons on the right side. If we scroll down to lines 38 and 71, here is the option to rotate. So you would just uncomment this. And then 71, uncomment this. Hit Control S to save and Control X. Now I did not do this under sudo, so it's not going to actually write this. And then just restart Chromium once again, and it's going to put it into landscape mode. Now one more thing I do want to check out is the adjustment for backlight brightness. Now to modify the brightness of this Spotify car thing, we're going to do nano scripts setup display.sh, and under here we can see the setup mode, the default portrait orientation, and everything else modifiable for the user. And then if we do backlight instead of display, here we can see the basic default brightness went on, how often to check the state of the display, and then the control for the brightness. Now, if you're looking for the screen timeout, I did say it is under the xorg.config. And here's the default standard basic timeout. You would just modify these values. And that's it. All the documentation for specifics can be found on the GitHub page itself. Now, I like this because it leaves a lot to create your own off of this, especially since it has touchscreen functionality, buttons, and pretty much everything seems to work, unlike our previous Debian CH root. But that was the start, and this is better. Now don't forget, these are all proof of concepts. They're not always going to work. I always try to add the fix that I find into these videos. For example, again, if it doesn't work, just put the command on screen to add that value. If you have any issues, just let me know down in the comment section below. I will try to assist you as best as I can. Now, if you found this tutorial helpful, even in the slightest, consider subscribing for content like this. We still have our Windows tutorial to cover this. The process is practically identical, just the tools that we use are different via Windows. Again, any issues, comment down below. I'll try my best to assist. Like if you like, dislike if you dislike it, and I'll see you all in the next video.